Welcome to Unit 2, Lesson 1, Part 1, Radical Functions and Transformations. So prior to this, we've been looking at how to move graphs around and reflect them over different axes. And now we're going to continue working with those inverse functions and radical functions. So a radical function is a function that involves a radical with a variable in the radicand. And that word radicand means under the square root symbol. So these two here are examples of radical functions. A radical function is a reciprocal function of a quadratic function, which is restricted. So if, for example, we use f of x is equal to x squared, then we find that inverse, so x equals y squared, and then flip it and take the square root to solve for a y, and therefore f to the negative 1x is equal to the root of x. So when we plot that on our graph, it looks like this. We have our table of values here. You can see that our y values are the square root of our x values. So we've restricted the domain. Our restriction is x is greater than or equal to 0, and it starts here at that origin point. Now, when we highlight our domain and range for this graph, we see that our domain, it goes from 0 to positive infinity across the x's. Just going to add an x and y here. And our range also goes from 0 all the way into positive infinity for the y's. Everything you've learned so far about A, B, H, and K still stays the same. They still do the same job. So A is a vertical stretch, B is a horizontal stretch, H moves it horizontally, and K moves it vertically. All the stuff that you've already learned, it still applies. Don't overthink it. It's exactly what we've already been doing. You know how to do this. So for our first example, draw the radical function y equals the root of x minus 2. Now notice that the x minus 2 is all under the square root symbol. So that minus 2 is our h, not k. It's h. So it's a horizontal shift. Now, what we want to do is determine the restriction first. So we have x minus 2 is greater than or equal to 0. And you just add 2 to both sides. You treat the greater than or equal to as an equal sign. And we're adding 2 to both sides. And therefore, x must be greater than or equal to positive 2, which is shown on our graph right here. Now, we have our mapping points. F of x is equal to the root of x. Y is equal to the root of x minus 2. So, just like we did before with h values affecting the x coordinates, we are going to take the opposite sign of the h value and add it to the x. So our new mapping points will be x plus 2, y. Now when we're considering our f of x, we're using that base graph, y equals the root of x. So it's going through the origin there and up. And you can see we have our image points of our original graph and what they will become in the new graph. Now it's really simple. You already know how to do this. We're just describing how the graph has moved. So it's just 2 units to the right because h equals 2. Our domain for this graph is positive 2 to infinity, and the range is 0 to infinity. The second example here, it shows a vertical shift of minus 3. Notice that the negative 3 is outside the square root symbol. That's our k. Therefore, our graph just shifts down 3 units. So exactly the same as we did in the previous example, you have your x, y coordinates to start with, and we're just showing a shift in the y coordinates of down 3. So you can see here that the whole graph starting from 0, 0 just moves down 3 units, and then you just plot the graph as usual. Now the domain here is 0 to infinity, and our range goes from -3 as our minimum value to infinity as our positive value or maximum. Beyond this, you have some practice questions. I just wanted to highlight for you, don't forget that A and B still have their same job. So just a hint, in this question, you're doing a vertical stretch of 3 and a flip. And in this question, you're doing a flip and a horizontal stretch of 1/2. Keep that in mind when you go about your work.